Okay, I take it that it's 11 o'clock, so I'm going to make a start, if that's okay. Can people keep it down, because I don't have a microphone for you guys. Okay, so I'm on. Thank you. Trustable Software Framework, an attempt to change some stuff in the world. We'll see how we get on. First of all, I'd like to say a great talk by Imanol. We're working in exactly the same area. He's way more technical than me, so there won't be any statistics in this. But we do fully support the concept of statistics for assessing software. So just a very brief thing. CodeThink, I hope, is known to quite a few of you. We're specializing in open source. We do a lot of software engineering for international scale clients, and we tend to recommend open source for everything. That means that we have lots of friends, but also we make some enemies, particularly in the proprietary world. So here's a question that we've ended up crystallizing, particularly in the last few years. And as we ask it, people kind of assume that this is a stupid question, but it's not. I would like you to all take away from this talk, why are we trusting software, right? And at the bottom there, this is the actual official way to install Rust. Now, I'm not calling out the Rust community. Rust is one of the most sensible communities in terms of protecting its supply chain. But to install Rust, you are surrendering control of your machine, and you're pulling some stuff from the internet, and you're saying, here, go. Okay? So you are trusting the Rust community, and you're trusting that command line when you do it. Right? Many software programs get installed exactly that way. It's a risk every time you do that. Right? Who are the people behind that thing that you're trusting? Now, our journey on this specific topic got started in 2016. We were asked by Bosch how open source could help with safety. Now, Bosch, for those who don't know, has made billions of braking systems for cars, so they're pretty good at safety, right? The question came up because people in Bosch were starting to realize that the systems are getting much more complex. Historically, they could put all of the stuff together themselves. They could design silicon, design hardware, write software, all the way up, turnkey system, bang, Bosch, certify, okay? But then customers are demanding, oh, can you use QNX? Can you use this third-party silicon? Can you work with this board? Can you integrate all of these other suppliers? That's a very different risk profile, and it's much harder. So they started thinking, well, how do people achieve that kind of interaction between all these different things? Oh, open source is pretty good at that. Let's have a go. So we started a research project, and the answer, very quickly, we stopped the research project because, first of all, there was no overlap between safety and open source. That may not be obvious to you. Please think about it. This is the one bastion of human activity where high tech is concerned, where it's still not open source. It's mainly proprietary solutions, secret behind closed doors. Very, very strange, don't you think? Right? But the answer that came back was you can't use open source for safety. This was from other guys in Bosch. And the reason is it doesn't comply with the standards, doesn't have requirements, so you can't say what it's supposed to be doing. It doesn't have an architecture, so you can't say that you've designed something to satisfy the requirements, and it has no traceability to say what the software is doing. Okay? So that is enough to stop open source in its tracks versus safety. Now, the standards. That's some of the standards that we're aware of that deal with safety. Some of them are all linked to this 61508, which Imanol mentioned. That's a well-established standard, over 20 years of history, and it's worked well for a whole lot of industries, but it's spawned these child standards in different industries. CodeThink, for better or worse, has been dragged kicking and screaming into the automotive industry and then into autonomous vehicles. Right? And years ago, in discussion with my colleagues, some of whom are here, the thought was, do we really think this is safe? Probably not. But we'd rather be in there finding out what people are thinking of doing than just standing on the side and watching the proprietary guys make this stuff. So we got involved. Right? Now, you've all seen that, I hope. The underlying tenet here is we're trying to get to a change in how this standardization process works so that people can actually see what's going on, particularly with regard to safety. Right? So that's the ex-CICD view, and we are in danger of just creating yet another idea, which in this context is the Trustable Software Framework, to compete with all of the other stuff that people have been working on for decades. Okay? Very little chance of success, but hopefully I might at least engage some people to think about the issues and why we're trying to do it. Okay, so here's one thing. are you aware that if you want to be a safety expert, you're going to have to spend $5,000 to read this document, and if you buy it, you can't then share it with your colleagues? We paid that money, and accidentally our finance director bought the document. And then we were told that the rest of us couldn't read it. So in public, on what was Twitter, which I no longer have anything to do with, I called them out and said, in effect, this is a Ponzi scheme. You're asking us to pay for work which is done by experts for free, but you're charging $5,000 for it. So we got our money back. Then we had to buy the 26262 standard, which is, so we have, in the end, paid for a copy of the standard. But, this is ridiculous. The licensing of it and the cost of it, this is about public safety. Why is this all so secret? So I just want to dig a bit deeper into one of these standards, the automotive one, which we've been wrestling with now for quite a long time. They have this fundamental assumption in 26262 that if you are working with software, if you do it right, if you have your architecture, you code it properly, you test it properly, then it will be perfect. It will never fail. Fantastic. Maybe that was true back then when those guys were working on their software before Git existed and before Linux existed. But that's not the world we are in now. We do not have deterministic software, as Immanuel argued very coherently. Right? The trouble with that is that assumption means that everything in that standard is about process. Right? It's not about how good the software is, really. It's about how you follow a process. And they will literally argue that you can't use Linux and open source. Rather, you should write the whole thing from scratch. Ludicrous. And to be clear, the processes they're advocating aren't used in the world anymore, in most of the world. So you're either working agile or open source or both in most organizations that innovate software. Whereas, these guys are talking about the V model. I'm not going to bore you with that, but basically it's the 90s came back and demanded that we still do it their way. So, no open source. I'm going to keep skipping forward because I have lots of slides. So, we're not in Kansas anymore. That's the Wizard of Oz quote. This is ISO 26262 down here. I'm sorry, I'm off camera now. Right? We're down with a microcontroller, up to 10,000 lines of code. That was the kind of systems these guys were wrestling with. And I don't want to criticize the work that went into this. For that kind of software where you're doing it from scratch, great. Makes perfect sense. That's not the world we're in now. We're in non-deterministic hardware, because anyone that's spent any time with microprocessors will know that you have caching. You have all kinds of optimized firmware, and the result is it's not deterministic. How do you think your software is going to be deterministic on top of it? Right? And then we're in the situation with some of our customers where it's not just a microprocessor, it's a multi-core microprocessor, but then there's multiple boxes with multi-core microprocessors in them, so we're dealing with all of the complexity of that. Again, not deterministic. Get it through your heads. So here's our assumption. We have to accept that, yes, we can process-wise screw it up, but we can also just experience random behavior that we weren't expecting. Right? 100% code coverage, fantastic in concept, broken in practice. It's never worth doing. Right? We are dealing with all of this caching stuff, and then all of the millions of lines of code that are in our supply chain, all of the compiler stuff, all of the dependencies, everything. Right? It is ridiculous to think that you're going to insist on specs and architecture and guaranteed process for all of that, and as a result, you will have something that you know what it does. Now, this 61508 standard makes these demands in terms of failure rates, right? And it's good, we've got some numbers. The trouble is, as I understand it, and maybe there are people in this audience who could correct me, nobody actually achieves those standards, right? This, 10 to the minus 8 to 10 to the minus 7 failures per hour, in effect, is one dangerous failure in 1,140 years. Who is going to be here testing for that long? It's not going to happen. Right? It's a very hard target, and as I understand it, what really happens in practice is people get scared of those numbers and they say, oh, well, I'll just follow the process then. Right? And if you follow the process, you're compliant, you get your cert without actually achieving the target. So, this is an old topic. I've been banging on about this in private and in public, to some extent, since 2016. So, I created a public mailing list, which still exists. It's been very quiet for a few years as we hunkered down and tried to work out what we were doing. But that's the email I wrote, and I basically spelt out as a call to action to older people like me, from different communities. Could we have a thought about what we'd actually need to do to get to promises for software at the kind of scale we're dealing with? And no, we're not going to rewrite it all in Rust, much as I would love to believe that we could do something like that. So how do we make promises for the software that exists, not the software that is in our mind's eye kind of thing, right? So that was the original call to arms, that we would know where it comes from, how to build it, how to know what it does, how to know what it is supposed to do, and we can compare those two. And also that we can make updates, because as Imano pointed out, we're in this process of rapidly changing software. So the key thing we learned, and we did learn quite a lot more, there was lots of discussion, the mailing list is still there, please browse at your leisure if you're interested in history. But the main thing was, if you want to trust software, then you will need some evidence, ideally, right? You would want to see evidence, and then ideally you'd rely on other people reviewing the evidence as well as you, and there would be some consensus. Right? Now, here we are at the topic of the talk, with approximately 20 minutes to go, almost, that's good. Sorry, I'll go back for that. So, Trustable Software Framework. Let's be clear about why this word was chosen. Trustable is different from trusted and trustworthy. Imagine if you're in China and you're offered software from America at the moment, or vice versa. Imagine if you're in Europe, offered software from some Middle Eastern country, whatever it is, right? Provenance does matter. I would love to say that we're all human beings, why can't we all just get along? But there are pre-existing biases, okay? And most of us would think differently about software depending on its provenance. If it's been created by people I know and trust and love, I'm going to treat that with a different view. So provenance is a crucial thing, but also I want the evidence to exist, rather than you telling me. I mean, I'm a bugger for this. I go around the world saying I've not lied in business, right? I haven't ripped people off, and I hold to that, right? But does that mean I'm trustworthy? You've got to decide. And you might want to check the evidence of that, talk to my former colleagues or whatever, right? So trustable means give the evidence and then let the recipient decide whether to trust it, as opposed to asserting, I'm trustworthy, okay? So we recently announced that we're moving a lot of our stuff to the Eclipse Foundation, because, frankly, the Eclipse Foundation has a big network of trusted parties contributing and trying to advance the state of the art of open source software. And in particular, they're working a lot with the automotive companies around this software-defined vehicle topic, whatever that means. So we're migrating this work, the Trustable Software Framework and some other stuff, into Eclipse, and we'll be batting from that base. Now, crucial thing about the Trustable Software Framework, first of all, it's conceptual, but then there is some software, okay? So these are the concepts. So you remember that call to action I wrote in 2016? We've tweaked it slightly, but still the same things apply. And I reckon these will still apply in 10 or 20 years, because they're fundamental stuff. It's not specifically about software. We will need to know where it comes from. Because we are going to be having to maintain it, we will need to be able to build it reliably and know what we built. We will need to deal with changes. And as Imano said, a ridiculous rate of change in the kernel, but it's not just the kernel. From our point of view, we're talking about software that's going into a vehicle. That's all of the kernel, the bootloader, and all of the system libraries and dependencies, and all of the userland stuff, and then all the supply chain, tool chain that was used to build all of that is what we would need to trust. And all of that's going to be evolving rapidly. So whatever we do will need to be automated. We'll need a test strategy that is applied automatically on every single release of the software. We need to know what it does. And we need to know what it's supposed to do, and then we need to know what it must not do as a result of what it's supposed to do. Okay, so simplistically, you might start with a car and say, well, it must drive, and it must not crash. And then you can build down from that. You can start breaking down the individual things that would affect whether it will crash or not. Okay? Then whatever we've established as that basis for this is what it's supposed to do and what it must not do, we will need to test the hell out of it. We will need to figure out how to get to a confidence level, because it won't be deterministic. So Imanol's got a very advanced argument around some specific statistics. We're working on complementary or different statistics, but in the end, it's going to be a whole load of maths combined with test results to figure out how confident are we that this thing really does what we think it does and won't misbehave. Okay? And in the end, all of that needs to be measured. So all of those factors there we're arguing if you want to trust something, you need to be able to measure all of that content and iteratively, repeatedly, get to a confidence view. Okay? Now, this is our open attempt to describe how you should get to confidence. Thank you. So, Trustable Software Framework, you can't see that, but you can see it on the website now. The link is at the bottom. That's temporary because it will go to Eclipse at some point, but the website is open. The top row here, that's those 6 tenets, and then the next 2 rows are breaking down into some more detail of what will be required. Seriously, folks, it's on the internet. You get better pictures that way. Okay, so I'm just going to run through briefly. So this left side is literally just about the supply chain stuff. It's demonstrating you know where your tools came from, where all your dependencies are, all of that stuff. This is demonstrating you can build it. And I saw recently the FreeBSD project came up with this phrase, zero trust builds. Please, let's raise that topic. That's the thing. You should be able to build all the stuff without root. You should be able to build it without the internet. And you should be reproducible. If you build the same thing 3 times and you get 3 different results, then you're doing it wrong. Okay? This CICD for everything. So you will need to be able to react and take fixes from upstream, whether it's releases or emergencies, security updates. So whatever promises you're making beyond this, if you can't do that while consuming all of those updates, again, you're not doing it right. This is the expectations, and this is our equivalent to requirements. In effect, there's a whole lot of history around how you define requirements. And our advisors in Exeter have said, you know, after a full career, Jonathan Moore said, he's still not seen a great set of requirements from anybody. And that's over 40 years, right? So we're not calling it requirements, we're calling it expectations. And the basic principle is we should only define what really matters. We're not trying to create thousands and thousands of requirements. Let's just focus on what really matters and try to get to the key promises that this software is supposed to be making. That's the results. And I'm going to digress here because to pick up on Imanol's talk. So he was asked, are you dealing with changes to the kernel, right? So I'm not going to explain all of those graphs, but you can broadly see that we have some kind of distribution. We have a target here. This is what we're trying to schedule on. And depending on the hardware, so we're starting with virtual on the left, an Intel box in the middle, ARM box on the right. We have different distributions of testing, but that data is being collected as we rev the kernel and everything else. So the whole distro is being revved, and we're building up a model of test data over time for all of the changes that we're having to adopt. So we're getting into a situation where we can understand how change is affecting the results, not just some one version of the software. Confidence is about getting to a measurement. And let me get... Well, I'm still good for time, I think. I'm doing better than I thought. I'd like to give a shout out to the Doorstop project. It's a relatively small project, but this is an initiative started by a chap who did a PhD around this topic, and he's one of the people who realized, oh, proprietary nonsense. So Doorstop is an attempt to replace DOORS. DOORS is IBM's historic requirements management system, very complex, very proprietary, and I don't know what it costs now, but certainly historically very expensive. This is just some Python code and some Markdown and some YAML, and it works really sensibly, provided you're thinking simple, command line type, automatable type requirements management. We've based the Trustable Software Framework on that, although we're actually improving for our use case with some specific tweaks. The net result of the framework is getting to an automated report of all of the evidence assessed numerically, in effect. So it's a measure of how confident we are in each of these topics. And the aim is that someone could drill into this and say, well, am I confident in the supply chain? Have these folks really thought about what matters in their use case? Are they able to defend what they're doing and what could go wrong with that? So you can drill into the numbers in each individual component. And the idea is to get to trustable score for software equivalent to or like a credit score for a person or an organization. Okay? Now, we're not assuming that all software projects are going to adopt this anytime soon. But if you think about the CRA, there's a requirement on a subset of the community, particularly the stewards and the manufacturers, to make an argument about how they're dealing with security best practice. Okay? So some organizations that are supplying open source really should in our view, get to grips with how they're going to make promises about the supply chain that they're dealing with. So this doesn't necessarily apply to every single individual project, but it could be applied, and we are aiming to apply it at the aggregation distro level kind of thing, or at the system level for a vehicle, in our case. As a side note, we're open sourcing, super, thank you. We're open sourcing a small open source project developed in Rust, shout out for Rust, which does safety monitoring. So this, in effect, is a small userland program that will check various parameters. It's configurable, and it will report on whether those values are being satisfied at the right frequency, in effect. So there are various proprietary safety monitors. We're hoping that this can become a popular open source one. So it's a way of monitoring things happening in a Linux-based system. And we've literally only just plugged in the Trustable Software Framework to it. The work over the next few months will be to demonstrate how people get to grips with the Trustable Software Framework and get to some numbers that will then be maintained with the project. Takeaways, it's fully open source, it's going to be Eclipse, it's mostly automatable. I would love to say it's entirely automatable, but it's not, because at some point people have to review the stuff and decide whether they think that anything's been missed. It's designed to complement existing processes, so we're not trying to change everyone's process and get them to switch to this instead. It should fit alongside what people are already doing. And it's particularly applicable for existing software, including open source. It's extensible, so one of the things we're doing in the background, we're explicitly mapping one of the standards, 61508 in our use case, to Trustable Software Framework. So we're trying to get to a certification approach that allows us to, over time, gradually say, well, we don't need the standard because we're using Trustable. So that's the strategy. And there's loads of work to do. So if anyone's interested in this, please do get in touch, either via the list, which I'll give you the URL for in a minute, or email directly to me, or get in touch with CodeThink in general, or via issues on the projects. So thank you. Okay. Yes, Philip.
I would see that you have, if you like to say, write down the expectations and check how the expectations are met.
Yep.
That this is one of the most review-intensive parts, right? It means
correct.
If you have a small project or whatever, it could still mean you need to have a lot of understanding in order to give such a credit score. Like how is your idea to manage these kind of skills that you can really judge and give a score?
Okay, so Philip's asking, given that this could be a lot of work, how would this be made to work for a small project? And the answer is, I don't believe small projects should be going anywhere near this anytime soon. The onus is on people who are trying to make promises around use of software to figure out how to make the promises for their whole solution. So, in effect, we're mainly thinking about this holistically and not trying to drill into every single component, which in a way is a corollary of what Imanol's saying. Trying to get to 100% code coverage is a fool's errand. Trying to do this level of work on every single library, I don't know what we're up to in our solution at the moment, but it must be of the order of 1,000 different components. Trying to do a detailed assessment of what all of those components are doing is not going to work. And I don't believe that the credit scoring does all of that level of data either. I think in the end you need actuaries, mathematicians, statistics folks figuring out how to get an overall sense of risk without having to drill into every single detail. I think, yes, one more, sir, quick.
I was interested in aerospace.
Okay.
You left out the topic of certification on purpose. So, for example, if you present this to the authorities,
Yes.
what would you get as an answer? What's enough?
Yes.
You cannot do that. You cannot just say, well, there's a score. That's
Okay, yes. So the question is, yes.
But I couldn't figure out, from this talk.
Yep. Okay, so the question is specifically with aerospace, but it's more generally, how does this lead to certification? And yeah, there's going to be a body of people in any industry saying, well, okay, why should we trust this? Okay? As I understand it, in most of the current certification approaches, that question is always used. You know, how do you know you've done enough? And the typical answer tends to be, as I've heard it distilled down, we put the right people in the room, they do the work, they say they've done enough, right? And then you check with the standards, okay? So this is not a solved problem. We may still fail, but it's a genuine attempt to establish an open source way of doing this. So I would say it's a very good question. Our aim with CodeThink is to achieve actual certifications. We have one ACLD tool cert for part of what we're doing in this regard. The aim is more certifications that show that we can achieve this kind of approach and meet the standards, and then hopefully deprecate the standards, frankly. Okay, I think that's enough. Yep, super. Thank you very much.